Dear students, my name is Bhanu Prakash. Today I am going to take a class in chemistry in the topic atomic structure. Atomic structure begins with the basic question, matter. What is meant by matter? Anything that occupies space and has got mass can be called as matter. For this matter, anything can be taken as an example. Say, myself is an example for matter. You for yourself are example for matter. Because both of us occupy some space and we are associated with the weight. Composition wise, this matter can be classified into two basic forms. One is called elemental form, another one is called compound form. The elemental form is made up of small particles called as atoms, whereas compound form is made up of small particles called as molecules. This atom is further found to be made up of three particles, namely electron, proton and neutron. These three particles are called as fundamental particles of matter. Electrons, as you all know, carry 1 unit of negative charge, protons will carry 1 unit of positive charge and neutrons no charge. So, the problem is electrons and protons, they are oppositely charged particles and they always try to attract each other. And in that process, if the particles come in contact with each other, a process called as annihilation takes place. And in this annihilation, matter will be converted into energy form according to Einstein's mass energy relation, E is equal to mc square. So, if that happens, existence of atom is not possible and as a result, matter also cannot exist. Right? That means these particles are arranged in such a way so that even though they are oppositely charged particles, they do not attract each other. Now the question is how they are arranged in the atom, which is a small particle. So study of the systematic arrangement of fundamental particles, that is electrons, protons and neutrons in the atom, can be called as atomic structure. So in order to explain the arrangement of these three particles, from time to time, various models have been developed and they are called as atomic models. Till date, 5 atomic models have been developed. J.J. Thomson's atomic model. Next atomic model is called Rutherford's atomic model. An improvement over Rutherford's atomic model is Bohr's atomic model. And then came into picture Sommerfeld's atomic model. And the latest one that we are making use is called wave mechanical model of atom. This wave mechanical model of atom is also called as quantum mechanics. So, for the competitive examinations, our main focus will be on Bohr's atomic model and wave mechanical model of atom. But before going into the detailed study of Bohr's atomic model or wave mechanical model, first we should be aware of the concept of electromagnetic waves. What do you mean by electromagnetic wave? As the name indicates, it consists of two components. One is called oscillating electrical field and another one is called oscillating magnetic field. Both these components are present in perpendicular directions to one another, and they are perpendicular to the direction of movement of the wave also. So, to visualize the electromagnetic wave, you can make use of Fleming's left hand rule. Suppose you take these three fingers. Forefinger, if it represents oscillating electrical component, middle finger oscillating magnetic component, thumb represents the direction in which the wave is moving. All the three are perpendicular to each other, right? So, as the wave moves in this direction, into its perpendicular direction, magnetic field will be present, and again to the perpendicular direction, electrical field will be present. So, combination of oscillating magnetic field, oscillating electrical field acting perpendicular to each other and perpendicular to the direction of movement is called as electromagnetic wave. So, this wave is generally present between 2 points. Arbitrarily, one point is taken as a origin and one point is taken as a terminating point. This direction is taken as a mean direction. Based on the mean direction, the wave will be oscillating both in the positive direction as well as negative direction. If it is taken as positive, this will become negative. So, from mean position to maximum distance covered in the positive direction or in the negative direction is taken as the first property of the wave called amplitude. This peak point in the positive direction is called as crest, and in the negative direction, that is downward direction, is called as trough. So, amplitude can be defined as the distance from mean position to crest or mean position to trough, which is the first property of electromagnetic wave. Then, if you measure the distance between two successive crests or distance between two successive troughs, that is taken as a wavelength, which is denoted with the symbol lambda. Wavelength can be defined as the distance between two successive crests or two successive troughs, and this wavelength you can calculate by using this relation, C by mu. C stands for velocity of light, mu stands for frequency of the electromagnetic wave. The velocity of light is a fixed value, fixed quantity. In CGS system, it is taken as 3 into 10 power 10 centimeters per second. In MKS system, it is taken as 3 into 10 power 8 meters per second. Then, if you consider one particular point in the mean direction, through that point, how many times the wave passes in 1 second, that number will be taken as a frequency. Frequency is denoted with the symbol mu, and it is calculated by using the relation C by lambda. Or in place of C by lambda, we can make use of the term 1 by T also, where T refers to time period of the wave. Then, these three properties are not dependent on any other, hence they are called as primary properties of electromagnetic wave. Based on these properties, some other properties come into picture, which are called as secondary properties of electromagnetic wave. That is wave number. Wave number is denoted with the symbol mu bar. It is the reciprocal of a wavelength. Then energy. It is dependent on both frequency as well as wavelength, calculated by using the relation E is equal to h nu, or in place of mu you can make use of c by lambda. This h is called as a Planck's constant, which is given a value of 6.62 into 10 power minus 27 Earth per second in CGS system, 6.62 into 10 power minus 34 joules per second in MKS system. Then the last property is velocity. Velocity is denoted with the symbol c. It is the product of frequency and wavelength. Definition that can be given to velocity of electromagnetic wave is distance travelled by a wave in 1 second can be taken as velocity. All types of electromagnetic waves travel with same velocity. Hence, this velocity is denoted with the symbol c, indicating constant value. It is independent of direction as well as medium, and its value is 3 into 10 power 10 centimeters per second, or 3 into 10 power 8 meters per second. Based on these relations, we will work out number of problems in this topic, atomic structure, which we will discuss separately. The Planck's quantum theory has been proposed to explain the origin and the properties of electromagnetic waves. So, according to this theory, how an object called source of radiation can produce electromagnetic waves. Whenever a body is heated to a particular temperature called as incandescent temperature, the emission of electromagnetic waves starts taking place. The energy can be supplied to the body either in the form of heat or in the form of current. Then the body will be heated to this particular temperature called incandescent temperature, and then it will start emitting the electromagnetic waves. So, we can say electromagnetic waves are a form of energy, and the emission of electromagnetic waves is a discontinuous process but appears to be continuous in nature. This is because the time gap between the emission of one electromagnetic wave and another electromagnetic wave is very short, which our eye cannot perceive. That's why the emission, even though is a discontinuous process, appears to be taking place in a continuous manner. And every time one particular wave will be emitted with specific energy, and the energy associated with each electromagnetic wave is called as quantum. In German language, quantum means how much. One quantum value is given as equal to h nu. H stands for Planck's constant, nu stands for frequency of the emitted radiation. The number of electromagnetic waves emitted can be calculated by using this relation: total energy emitted is equal to n into h nu, where n stands for number of electromagnetic waves emitted by the source of radiation. N value will be always integral in nature, And according to this concept, electromagnetic waves are purely treated in the form of waves. Each wave is given this specific name called as quantum. One more theory has been proposed to explain the properties of electromagnetic waves, which is called as Einstein's Photon theory. According to this theory, electromagnetic waves are not considered as waves but as made up of material particles. Each electromagnetic wave is considered as equivalent to a material particle called as photon. Every photon is associated with a mass m and moving with the velocity of light c. Therefore, energy associated with one photon is given by this relation E is equal to mc square. Later, this relation was called as mass energy equivalence. That means mass can be converted into energy, and conversely energy can also be converted into mass. So according to this photon theory, electromagnetic waves are considered as made up of material particles called as photons, and all other aspects are same as Planck's quantum theory. So, which is true? Electromagnetic waves, are they made up of waves or are they made up of material particles called as photon by Einstein? Answer is both are correct. Electromagnetic waves are associated with a dual nature. That is, at a time they can behave as waves as well as material particles. Electromagnetic spectrum. The general meaning of spectrum is a systematic arrangement. Say for example, if you take a classroom, the students are seated in a systematic manner, and that is what we call classroom spectrum. Similarly, if you arrange electromagnetic waves in an order, either in the increasing order or decreasing order based on their properties, that arrangement is called as electromagnetic spectrum. So, when we make use of the properties to arrange, cosmic rays will come first, followed by gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwaves and radio waves. The frequency of cosmic rays is maximum and gradually decreases to radio waves. If you take wavelength, it is minimum for cosmic rays and gradually increases to radio waves. If you take energy, it is maximum for cosmic rays and gradually decreases to radio waves. So, with reference to frequency, the order is decreasing, wavelength increasing, and energy if taken again decreasing order. This systematic arrangement is called as electromagnetic spectrum. Now, how to record this spectrum? The apparatus used for the purpose is called as a spectrometer. The following parts. One is called source of radiation, which emits electromagnetic waves in all the directions. This source of radiation is placed in a concealed box with a small aperture so that we can get an intense and uniform beam of light that can be passed through an analyzer. In most of the cases, analyzer is a prism, and the prism will split the incident light into different waves and arranges them in an order based on the properties, which is recorded on a photographic film, which is called as a recorder. So here, if you make use of an ordinary bulb, the light emitted comes under the category of visible light. And visible light is made up of 7 different waves, which we call as colors also, and those colors are recorded in this order on the photographic film, called as Vibgr spectrum, also called as solar spectrum. V stands for violet color, indigo, blue, green, yellow, orange and red. In place of an ordinary bulb, if we make use of solar light, on the photographic film, you will get different waves starting from gamma to radio waves. Cosmic rays cannot be recorded because of their high energy levels. On the photographic film, visible part of the electromagnetic waves will be recorded in the form of colors, whereas other types of electromagnetic waves will be observed in the form of streaks of light, that is patches of light, and this apparatus is called as spectrometer, which is used for recording of spectrum. Types of spectrum. Broadly, any spectrum is classified into 2 types as emission spectrum and absorption spectrum. If the light emitted by the source of radiation is directly analyzed and the spectrum is recorded, then it is called as emission spectrum. In emission spectrum, spectral lines will appear very bright as the radiation is directly analyzed and recorded. Whereas in case of absorption spectrum, the light emitted by the source is first passed through an object and the transmitted light is analyzed and then recorded on the photographic film. So here, as the radiation is passing through an object, intensity of the light is decreased, and sometimes, depending on the nature of the object through which light passes, part of the radiation may miss also. In that case, in the recorded spectrum, black colored patches will be observed, indicating missing of specific electromagnetic waves. In general, the spectral lines observed in absorption spectrum will be dull, or sometimes complete darkness may be observed if the object absorbs all the incident radiation on it. So whether it is emission spectrum or absorption spectrum are further classified into 3 types as line spectrum, band spectrum and continuous spectrum. Line spectrum is also called as atomic spectrum, or it is also called as a fingerprint spectrum. Band spectrum, it is also called as a molecular spectrum. Line spectrum is obtained in case of emission spectrum when the source of radiation is in atomic state. When source of radiation is in atomic state, it will produce one particular electromagnetic wave only. Therefore, in the recorded spectrum, specific wave will be observed, and no 2 atoms will produce same type of electromagnetic waves. That's why This atomic spectrum is also called as a fingerprint spectrum. By means of this atomic spectrum, we can identify the presence of new elements. Band spectrum is obtained when source of radiation is in the form of a molecular state. As the name indicates, in band spectrum, number of spectral lines will appear in the form of bands. If the source of radiation is in bulk state, the spectrum what we observe is called as continuous spectrum. In case of absorption spectrum, the classification will be based on the state of the object through which radiation is passed. If the object is in atomic state, corresponding absorption spectrum is called as line spectrum. If the object is in molecular state, the spectrum is called absorption band spectrum, and if the object is in bulk quantity, that is called continuous absorption spectrum. So, total there are 6 types of spectrums which can be broadly classified under 2 headings as emission spectrum and absorption spectrum. Next is hydrogen spectrum. When hydrogen gas is taken in a discharge tube and subjected to high electrical discharge, that is high voltage current is passed through it, what happened? It has started emitting the radiation. When that radiation is passed through a small hole called aperture and analyzed by using a special prism called as Nicol prism, number of electromagnetics were observed in the recorded spectrum. Some of the electromagnetic waves were found to be in ultraviolet region, some were observed in visible region, and some were observed in infrared region. The spectral lines observed in UV rays, they were studied by a scientist called as Lyman, and hence those spectral lines are collectively called as a Lyman series of spectral lines. Visible region was studied by another scientist called as Balmer, and hence collectively the spectral lines are called as Balmer series of spectral lines. In infrared region, number of spectral lines were observed, and these were studied by 3 different scientists, namely Passion, Brackett, and Fund. And based on their names, they are called as Passion series of spectral lines, Brackett series of spectral lines, and Fund series of spectral lines. Now the question is, hydrogen is a simple gas, simple element with only 1 electron in it. So, how such a simple element can produce so many electromagnetic waves? That too in 3 different regions of electromagnetic spectrum. That is called hydrogen spectrum, and answer for this hydrogen spectrum was given by Bohr's atomic model. In order to calculate the wavelengths of various spectral lines observed in the series, Rydberg gave an equation called Rydberg's equation. Nu bar is equal to 1 by lambda, that is equal to RH into 1 by N1 square minus 1 by N2 square. RH is called as Rydberg's constant, which is applicable for only hydrogen. Its value is taken as 109678 centimeter inverse. For Lyman series, N1 is fixed at 1, N2 values are taken from 2 to infinity. For Balmer series, N1 is fixed at 2, N2 is taken from 3 to infinity. For Passion series, N1 is taken from 3, N2 value from 4 to infinity. For bracket series, N1 is taken as 4, N2 5 to infinity. For fund series, N1 is taken as 5 and N2 values are taken from 6 to infinity, right? And in each series, the spectral lines are given specific names, what we call designation of spectral lines. In any series, if the difference in N1 and N2 values is equal to 1, that line is called as alpha line or first line. If the difference is equal to 2, that will be called as a beta line. If the difference is 3, gamma line, and if the difference is infinity, then it is called a limiting line of spectrum, or it is also called as a infinite line of the spectrum. So, in Lyman series, you can name the spectral lines as first line, second line, third line, up to infinite line, or you can make use of the Greek alphabets alpha, beta, gamma, etc. up to infinity. Similarly, in Balmer series, Passion series, bracket series, and fund series. Dear students, in today's class, we have discussed what is meant by atomic structure, various atomic models, and particularly the concept of electromagnetic waves, their origin, their theories, and the spectrum, types of spectrums, and what is meant by hydrogen spectrum. In the next class, we are going to discuss the atomic models, particularly Bohr's atomic model and wave mechanical model of atom, how they have explained the hydrogen spectrum as well as the structure of atom.
The wavelength for a spectral line emitted by hydrogen atom in the Lyman series is given as 16 by 15 R. What is the value of N2? Where R is taken as Rydberg constant. This equation is based on the Rydberg's equation. As the spectral line is in Lyman series, N1 value is fixed at 1. We have to find out N2 value. So, for that we can proceed like this. In place of lambda, we can substitute the given value 1 by 16 by 15 R is equal to R into 1 by 1 square means 1 itself minus 1 by N2 square. So, this comes out to 15 R by 16 is equal to R into 1 minus 1 by N2 square. 1 by N2 square is equal to, we can get 1 minus 15 by 16, that comes out to 1 by 16. From this, N2 value comes out to 4. So, correct option is C. Second question, the maximum number of sublevels, orbitals and electrons in n shell of an atom are respectively. N shell means it corresponds to, N shell means it stands for 4th orbit. So, number of sublevels is equal to number of the orbit itself, that is 4. Then number of orbitals can be calculated by using the relation n square. When n is equal to 4, n square value is 16, and maximum number of electrons that can be accommodated is equal to 2n square. So, that comes out to 32. So, correct option is 4, 16, 32, which is present in C. So, for this question, correct answer is C. Third question, the uncertainties in the velocities of two particles A and B are 0.05 and 0.02 meters per second respectively. The mass of B is 5 times to that of A. What is the ratio of uncertainties in their positions? This problem is based on the Heisenberg's uncertainty principle, which can be represented as m delta x delta V is equal to nh by 4 pi. For A, if we write m into in place of delta xa, and in place of delta V value is given 0.05 is equal to nh by 4 pi. Let us call it as equation number 1. Then applying the same relation to the particle B, it is specified that mass of B is 5 times to that of A. Therefore, for B, when you are applying the Heisenberg's equation, in place of m, let us take 5m into delta xb into delta V is specified as 0.02 is equal to nh by 2 pi. Now we have to find out the ratio between uncertainties in the positions. So by dividing first equation with the second equation, delta xa by delta xb is equal to, we can write 5 into 0.02 by 0.05. This can be represented as 2:1. So the correct option can be taken as the first option A. Fourth question. The energy of a photon is given as 3 into 10 power 12 ergs. We have to calculate its wavelength in terms of nanometers. The energy of a particle can be calculated by means of this relation. We need to calculate the wavelength. We will make use of the second relation. From second relation, lambda is equal to, we can write hc by E. In place of h, 6.62 into 10 power minus 27. In place of c, velocity of light, 3 into 10 power 10. In place of energy, 3 into 10 power minus 12. So this comes out to 6.62 into 10 power minus 27 plus 10 plus 12. 6.62 into 10 power minus 5 centimeters. When this centimeters has to be converted into nanometers, the conversion factor is 1 nanometer is equal to 10 power minus 7 centimeters. Therefore, it has to be divided with 10 power minus 7. So 6.62 into 10 power 2 we get, or 662 nanometers you can say. So the correct answer for this problem is first option A, 662. The atomic numbers of elements X, Y and Z are given as 19, 21 and 25 respectively. Number of electrons present in the M shell of these elements follow the order. So to solve this problem, we have to write down the electronic configurations of the given elements. X atomic number is given as 19, Y atomic number is given as 21, Z atomic number is given as 25. So for an element with atomic number 19, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. For element with atomic number 21, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. And for an element with atomic number 25, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d, 5. Now we have to count number of electrons present in the M shell. M shell means third orbit. In case of X, number of electrons present in the third orbit are 8. In case of Y, the number of electrons present in the third orbit are 8 plus 1, 9. In case of Z, number of electrons present in the third orbit are 8 plus 5, that is 13. Therefore, the correct order is Z greater than Y greater than X. So, we can take option C as the correct answer for this question. Sixth question. An electron is moving in Bohr's fourth orbit. Its de Broglie wavelength is lambda. What is the circumference of the fourth orbit? Orbits, they are circular in shape. Therefore, circumference of the circle will be equal to circumference of the orbit. The condition is 2 pi r is equal to n lambda. So, as it is fourth orbit, in place of n we have to substitute 4. So, 2 pi r is equal to 4 lambda. This option is present in C. So, for this question, correct answer is C, 4 lambda. Seventh question. Which of the following elements has least number of electrons in its M shell? M shell means third orbit, we have to count. The given options are A is potassium. For potassium, atomic number is 19. So, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So, in the third orbit, total number of electrons present are 8. For manganese, atomic number is 25. Electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 5. So, number of electrons present in the third orbit will be 8 plus 5, 13. For nickel, atomic number is 28. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 8. So, number of electrons present in the third level are 8 plus 8, 16. Then fourth option, scandium, atomic number is 21. Electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 1. So, number of electrons in the third level are 8 plus 1, 9. We have to identify the element with the least number of electrons. So, least number of electrons come in case of potassium. Correct answer can be taken as A, potassium, for this question number 7. Eighth question. If the electron of a hydrogen atom is present in the first orbit, the total energy of the electron is. The total energy of electron E is calculated as minus E square by 2r. So, the correct answer is option C for this question number 8. If the wavelength of an electromagnetic radiation is 2000 angstrom units, what is its energy in ergs? Energy of electromagnetic wave is calculated by using this relation hc by lambda. We have to calculate energy in terms of ergs. So, all the data has to be taken in CGS system. Planck's constant in CGS system is 6.62 into 10 power minus 27. That of velocity of light should be taken in centimeters per second. Wavelength also has to be converted into centimeters. 1 angstrom unit is equal to 10 power minus 8 centimeters. So, this on simplification will become 6.62 into 3 by 2 into 10 power minus 27 plus 10 plus 5. (9.93 into 10 power minus 12 ergs). Nearest answer can be taken as the first option, 9.94 into 10 power minus 12. Which one of the following statements is not correct? Rydberg's constant and wave number have same units. This is correct statement only, both have got same units. Lyman series of hydrogen spectrum occurs in ultraviolet region. This is also correct statement. The angular momentum of the electrons in the ground state of hydrogen atom is equal to h by 2 pi. This is also correct. The radius of first Bohr orbit of hydrogen atom is 2.116 into 10 power minus 8 centimeters. This is wrong because radius is calculated by using this relation 0.53 into n square. When n is equal to 1, r value should come to 0.53. So, for this the correct option is D. The energy of electromagnetic radiation is given as 19.875 into 10 power minus 13 ergs. What is its wave number in centimeter inverse? Energy is given, we have to calculate the wave number. Energy is calculated by using the relation hc by lambda. 1 by lambda represents the wave number value. Therefore, from this relation 1 by lambda is equal to, we can write E by hc. All the data has to be substituted in terms of CGS system. E is given as 19.875 into 10 power minus 13, h value 6.62 into 10 power minus 27, velocity of light is taken as 3 into 10 power 10 centimeters per second. So, this comes out to 19.875 by 6.62 into 3 into 10 power minus 13 plus 27 minus 10. So, the value is this is 10 power minus 23 plus 27, that is plus 3, plus 4. So, 1000, 10,000 is the answer. So, for the 11th question, correct option is D, 10,000. 12th question, which one of the following is not an isoelectronic pair? Isoelectronic pair means a pair of chemical species with the same number of electrons. So, we should check out the option where the number of electrons are not equal. Say in the first option, if you see Mg plus 2 means magnesium atomic number is 12, plus 2 means it has lost 2 electrons. So, number of electrons left out will be 10. C minus 4, carbon atomic number is 6. C minus 4 means it has gained 4 electrons. So, total number of electrons with C minus 4 are 10. So, this is isoelectronic in nature. So, this is not the correct answer. If you check the second option, N minus 3, nitrogen atomic number is 7, it has gained 3 electrons, therefore, number of electrons are 10. O minus 2, oxygen atomic number is 8, minus 2 means it also has gained 2 electrons. So, this is not the correct answer. Coming to third option, N minus 2 means 9 electrons are present, O minus 2, 10 electrons are present. Here the number of electrons are not equal, therefore, this is the correct answer. For 12th question, we can take C as the correct option. The energy of an electron present in Bohr's second orbit of hydrogen atom is. The options are given in terms of kilojoules per mole. The relation is E is equal to minus 1312 by n square kilojoules per mole. So, as it is second orbit, in place of n we have to take 2. So, minus 1312 by 2 square is 4. That value comes out to minus 328 kilojoules. So, second option B can be